Assalamualaikum. Kita baru lagi live nanya ni. Nak tanya Puan Siti Nozaimah ni. Puan Siti Nozaimah.
Saya.
Puan mewakili kepada Puan Erawati ke?
Ya, betul.
Betul.
Puan Erawati hospitalized. Dia ada operation hari ni. Jadi saya akan wakil dia lah.
Okey. Terima kasih.
Sama-sama.
Mounted on a Photoshop. Home is maintained the vertical position with distinctive angle oscillation by possible windows.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Kita akan memulakan sesi pembentangan untuk petang ini, iaitu tahun 2020 di Politeknik Sultan Azlan Shah. Untuk pembentangan pertama, kita akan jemput landscape arkitek Dr. Zanariah Kasim daripada Politeknik Sultan Idris Shah untuk membentangkan research yang bertajuk Effect of Landscape Environment Setting on Microclimate in Enhancing Pedestrian Thermal Comfort of Tropical Campus Environment. Secara ringkasnya ialah kesan daripada keadaan persekitaran yang mana untuk prosesnya berjalan kaki lah. Ada protein setting yang dia akan tu. Jadi kita akan memulakan sesi video terlebih dahulu, dan selepas itu kita akan mulakan sesi Q&A, dan diminta para peserta bersedia dengan soalan-soalan. Silakan.
I will be presenting our study with the title Effects of Landscape Environmental Settings Toward Microclimates in Enhancing Pedestrian Thermal Comfort of Tropical Campus Environment. Actually, this study is conducted by me and with my friends Encik Syarif Khairi and also Wan Nurul Fazlina. Right. The outline of my presentation, I will start with introduction, followed by literature review, methodology, and finally the result and conclusion. Right, for the introduction, this study is related to 3 issues. Issue number 1 is on campus and city sustainability. Issue number 2 is on health and well-being of campus community. And the third one is on how to promote pedestrian thermal comfort. Because if pedestrians are comfortable, we believe that we can promote walking to the campus community. Because in our countries, tropical climates, hot and humid, always be a reason why the walking is not popular among campus community. Actually, promoting walking to campus community or city dwelling it can reduce, one way to reduce the demand on fuel transportation, and also it can reduce the problem of traffic jam, especially in city center. According to Buchu 2013, she also highlighted that the idea of promoting walking among the city dweller will increase the business demand on the area. Alright, for the literature review, this study focusing on 2 main constructs, which is pedestrian thermal comfort and comfortable walking distance. Pedestrian thermal comfort is related to human thermal comfort. According to Porcher, et al. 2018, human thermal comfort is determined by the overall thermal comfort and the assessment of environmental quality. It does not only on physical parameters, because our body, psychological and physiological also responds to the environment. And Cascade and Pavlet 2013 revealed that the determination of what will make someone feels comfortable needs consideration on a range of environment, meaning that the microclimates parameter, for example, air temperature, globe temperature, the surface temperature, the relative humidity and wind velocity of the environment, of the microclimates environment, and the personal parameter, which are our metabolic rates and the clothing level, meaning what we are wearing at that times, also will affect to the feeling of comfortable. So therefore, this study will observe various landscape settings that influence pedestrian thermal comfort. For the comfortable walking distance actually is a crucial factor that for people in making decision either to walk or to choose transportation. Distance studies did by PSAS 2003, Lu et al. 2017, and Milward et al. 2013 find that distance to the nearest facility turned out to be an important impact factor, influencing the frequency of shopping trips on walking, meaning that distance is very crucial. Then they found that they agreed that 400-meter distance is a walkable distance. It's similar to 5 minutes walking from the house to any destination. And it's revealed that most walking distance are shorter than 600 meters and very few exceed 1,200 meters. Then the study is done in not in tropical climates, in a temperate country. In our country, tested on walking distance did by Diana et al. 2015 and Narahuddin et al. 2017, they found that in a rural area, people will walk up to 600 meters as compared to only 400 meters in urban area, meaning that the environment affect the distance and the comfortable of walking to the pedestrian. Okay, then studies on the outdoor thermal comfort are related to effects of surrounding environment towards pedestrians, such as the urban geometry, the height and width of the street canyon, and pedestrian level greening. Lots of study doing on this. However, study looking on how pedestrian thermal comfort and relates to comfortable walking distance is limited. Thus, this study will measure the comfortable walking distance based on various landscape settings of tropical campus environment. Right. Based on Kasim et al. 2018, they coined the terms of LESP, Landscape Environmental Setting for Pedestrians, based on their study on 5 campuses in Malaysia. The 5 types of LESP identified as Type 1, Type 2, Type 3, Type 4, and Type 5. What is the Type 1? Type 1 is no shade, meaning only the pavement, the pavement is the only landscape element in walkway environment. Okay, in the walkway environment, there is no shade, but only the pavement. So compared to Type 2, we put that method, that meaning there are only 2 landscape elements in walkway environment, which are pavement and man-made shading. Okay, in the walkway environment, there are pavement and only man-made shade. I hope you can clearly see in the illustration and the photos in the slides. And for the Type 3, there are 2 landscape elements in walkway environment, which is pavement and tree shading. Okay, meaning that in the walkway environment, pedestrians have the pavement and a row of trees on one side of the walkway. Okay, and in Type 4, there are 3 landscape elements in walkway environment, which are pavement, man-made shading, and the tree shading. And it's clearly shown in the slide. Okay, then finally for the Type 5, there are 2 rows of trees. There are 3 landscape elements in the walkway environment, which are the pavement and the 2 rows of trees. And I can see, from this slide, in the illustration, it clearly shows the different various types of walkway environment. Okay, after identifying 5 types of LESP in 2018, Kasim et al. In 2019 did the field measurement of 5 microclimatic parameters, which are air temperature, surface temperature, globe temperature, wind velocity, and relative humidity at these all the 5 types of LESP in a campus in Malaysia. So they identified the location for type 1, type 2, type 3, type 4 and type 5. And they do the measurement using portable instrument to measure all the 5 microclimates perimeter in this type, in all these 5 various types of LESP. And their result indicated that different types of LESP have different impacts on pedestrian thermal comfort. And the best of landscape types for pedestrian thermal comfort is LESP type 5, which is the walkway and the walkway have 2 rows of trees on the both sides. All right, for the research methodology, for this study we did the field survey in 5 types of LESP. So field survey was conducted in a UC campus in Malaysia under 5 types of LESP based on Kasim et al. 2018 and 2019. And total number of participants was 57. Participant who had given written consent to cooperate in this study. Participants were at the starting point between time from 12 to 3 p.m., which is the hottest time in a day in our country. They answer item in section A before started walking, and they walk to the first checkpoint to answer items in section B and repeat answering the item in section B at the next checkpoint. Participants walk along 250-meter walkway back and forth until the survey ends. It is because the length of walkway for the 5 types of LESP was only 250 meters. The example location of checkpoint in the walkway as shown in the slide. All right, survey ended when participants decided to stop walking at any checkpoint which she or he felt uncomfortable. Actually, this survey, the survey question in section B has 4 questions, which is measuring on thermal rate, thermal comfort, walking comfort, and walking distance. All right. Okay, this is the summary result of the survey in 5 types of LESP, which is what we have done. All right, the influence of 5 types of LESP on pedestrian thermal comfort and comfortable walking distance can be clearly seen from the result. All right, the LESP ranking in terms of pedestrian thermal comfort and comfortable walking distance in ascending order is, the first one is LESP type 5, followed by type 4, type 2, type 3, and type 5. And I will explain for each type afterwards. Okay, so in the type 5, the type 5, just now I already explained that in the walkway area environment there are pavement and we have, then have 2 rows of trees on the left and right, and the tree is very dense. Okay, so pavement and 2 rows of trees are landscape element in the walkway environment. So result from field measurement and field survey are in agreement with prediction that pedestrians felt most comfortable and comfortably walk longest in this type of LESP. Trees with dense and wide canopies acting as a shading device moderate the heat transfer from direct solar radiation to the ground. So perception on and walking distance, participants felt slightly cool, and for the thermal rate and for the thermal comfort, they feel slightly comfortable. Then slightly comfortable also for walking comfort, and the distance for comfortable walking distance is 996.5 meter, and almost if we round it to the it's almost to 1,000 meter or 1 kilometer. Oh, I forgot to mention that the result from the survey just now we analyzed using PSAS, and then this the the result from the PSAS using the mean, right? Then this the LESP type 4, result for LESP type 4, which is pavement, trees, and man-made shade are the landscape element in the walkway environment. Okay, result of the survey showed that participants felt better, meaning for thermal rate, thermal comfort and walking comfort, they feel neutral. Neutral meaning that they comfort, and the distance for this, the comfortable walking distance for this LESP type 4 is 800 meter. And the ranking number 3 is for the LESP type 2, which is pavement and man-made shade are the landscape element in the walkway environment, and result indicate that man-made shading, meaning man-made shading, which is the covered walkway, does provide comfortable walkway environment, because the participant feel neutral for thermal comfort, for the walking comfort, and the comfortable walking distance for this LESP type 2 is 650 meter. And the fourth ranking is LESP type 3, which is pavement and trees are the landscape element in this walkway environment, and result from this field survey show that participants felt neutral for thermal rate, thermal comfort, and also for walking comfort. Neutral meaning they feel comfortable, and the walking distance, comfortable walking distance for this LESP type 3 is 630 meter. And finally, the last ranking is LESP type 1, which is pavement is the only landscape element in walkway environment. The result indicate that this type 1 create a hot environment leading to heat stress and does not promote walking comfort to pedestrians. So meaning that for the designer avoid to provide this kind of walkway environment, walkway type 1 in the either in campus or in the city. Conclusion. So it is important to modify the solar radiation in walkway environment by having continuous shade either from trees or from man-made shade together, and it's good if we can provide man-made shade together with tree shades along walkway. And also man-made shading structure can only provide full shade, but the heat reflected from their surfaces can be quite considerable. Compared to tree will provide additional cooling effect as they reduce the radiation and provide additional cooling advantage through their evapotranspiration process. And the finding of this study may offer issues and problems in enhancing pedestrian thermal comfort. In addition, they may provide some contribution to the literature in the field of landscape architecture, urban design, and related field of study. For example, the number 1 is identification. This study and based on the study by Kasim 2018-19, and this study revealed that the identification of landscape environmental setting for pedestrian, which is LESP, types in tropical campus environment, and number 2, establish the relationship between landscape environmental settings and pedestrian thermal comfort. And number 3, our study also established the relationships between pedestrian thermal comfort and comfortable walking distance in all types of LESP. And finally, this study has expanded the guidelines in providing pedestrian thermal comfort for pedestrian walkway in tropical climates. With that, I end my presentation, and thank you very much.
Okey, terima kasih kepada Landscape Architect Dr. Zaneria Kasim dari Politeknik Sultan Idris Shah dengan kepentingan itu tadi. Jadi kita buka soalan kepada para peserta jika ada soalan. Dari platform Facebook ataupun platform YouTube boleh mengutarakan soalan. Jadi doktor, sementara menunggu soalan daripada para peserta, ada pertanyaan iaitu untuk keadaan environment di Malaysia, sebab kita fahamlah kebanyakan research dibuat di luar negara yang di mana mereka mempunyai keadaan empat suhu ya. Okey, sedikit gangguan, maaf. Okey, jadi di luar negara kita mempunyai keadaan di mana ada empat suhu kan. Jadi di Malaysia pula settingnya kita dalam keadaan di mana keadaan lembap dan panas, humidity lah. Jadi apabila doktor mendapat kita panggil finding daripada hasil kajian ini, setting yang mana yang paling sesuai dengan keadaan environment di Malaysia.
Okey, berdasarkan result study yang telah kami jalankan, environment yang paling sesuai untuk mempromosi berjalan kaki ialah mengikut jenis type 5, di mana di walkway environment terdapat pokok di kiri kanan. Okey, di kiri kanan yang mana pokok tersebut memang memberi teduhan yang paling penting, teduhan yang menutup terus kepada solar daripada cahaya matahari, dan dia berterusan di sepanjang walkway path tersebut. Dan yang kedua, jika tak dapat nak sediakan seperti itu, yang type 4, di mana type 4 dalam walkway environment terdapat continuous teduhan daripada man-made shade, maksudnya covered walkway, dan ada pokok, ada ditambah dengan pokok sebagai peneduh. So dia ada dua types of covered daripada sunlight dan suhu daripada ni. Maksudnya ada yang paling best tadi tu type 5, dan yang kedua ialah yang type 4.
Okey, bila saya melihat pertengahan doktor tadi, dia lebih kepada perlindungan untuk daripada sinar matahari lah. Jadi adakah kaedah ini juga meliputi dari segi pavement punya keadaan? Contohnya lah dalam keadaan tanpa batu-bata, keadaan jalan betak atau keadaan rumput ke. Jadi adakah kajian ini juga meliputi corak bentuk muka bumi itu?
Okey, dari segi pavement, sebenarnya kalau mengikut sebab kajian ini berdasarkan juga based on kajian terdahulu, iaitu yang dibuat oleh Kasim 2019, di mana pavement, walau apa jenis pavement, sama ada dari segi alphard, maksudnya alphard tu macam tanah jalan raya yang hitam kan, okey, ataupun pavement yang daripada yang pebbles yang putih tu, kira dia tak reflect sangat sahaba. Kajian hasil result daripada kajian membuktikan jika ada shade kepada cahaya matahari ataupun suhu, dia tidak memberi perbezaan. Maksudnya shade lagi penting daripada types of material of the pavement. Okey.
Okey, jadi untuk soalan seterusnya kita masih menunggu question daripada para peserta lah. Okey, yang seterusnya doktor, kajian ini dilakukan kita panggil di universiti awam lah kan. Okey, jadi adakah terdapat literature review yang mana dia dilakukan di bandar-bandar besar yang melibatkan orang-orang awam lah, contoh di Bandar Kuala Lumpur, Putrajaya dan sebagainya.
Okey, buat pengetahuan semua, setakat ini saya belum lagi menjumpai mana-mana kajian yang telah dibuat seakan ini untuk mengukur comfortable walking distance di bandar-bandar. Maksudnya dengan metodologi ini dan juga dengan kaedah ini, sebenarnya walking distance di Malaysia sangat limited dan kalau yang ada yang saya sebut tadi, ada dua daripada scholar tadi tu, Narahudin dan juga Diana, tu pun dia tidak mengambil kira jenis environment yang dilalui oleh pedestrian tu. Dikira jarak sahaja contohnya daripada rumah daripada tempat kediaman ke public transport station ataupun tempat menunggu bas ke ataupun train, tapi dia tak ada mengambil kira bentuk yang telah dilalui, environment yang telah dilalui oleh
pedestrian tadi. Sebenarnya kajian ni sangat bagus kalau boleh nilai untuk di-measure di bandar-bandar seperti Kuala Lumpur. Namun begitu memang memerlukan kesabaran dan masa lah, sebab kita perlukan ramai partisipan yang betul-betul boleh bagi komitmen, di mana cuba bayangkan kita minta mereka menjawab di setiap poin. Maksudnya kalau poin yang kami buat ni adalah daripada permulaan ke 50 meter dijawab sekali, dan 100 meter, dan berapa jarak yang mereka akan berjalan menjawab, sehingga memang mereka rasa dah tak selesa dari segi suhu, bukan letih berjalan, dari segi rasa dah panas dah. Jadi bila mereka kata mereka dah tak selesa, mereka dah berhenti berjalan, maka survey ini akan berakhir macam itulah. So komitmen itu sangat perlu, dan kami buat di ke-5-5. Maksudnya walaupun 57 orang responden, mereka berjalan di ke-5-5 types of LASP tadi. Maksudnya pada 5 hari yang berlainan dan berbeza. Satu lagi kami kena, sebab kajian ini adalah di outdoor, yang mana kami memang kena tengok konsistensi dari segi cuaca di luar, yang mana tidak hujan dan tidak mendung. Cuaca adalah, jadi kami sangat, maksudnya dari segi cuaca pun sangat agak sukarlah untuk, sebab kalau hari hujan kita kena stop, tak boleh nak jalankan kajian ini. Konsistensi dari segi suhu lah, daripada pukul 12 hingga pukul 3 sahaja. Saya rasa harap dapat menjawab soalan.
Terima kasih Dr. Sanaria Kasim. Jadi dengan tamat kita recap apa yang dibentangkan oleh Dr. Sanaria, iaitu mengenai pemilihan walkway ataupun walkway yang ada bumbung ke, ataupun keadaan campuran bumbung dan pokok-pokok, ataupun walkway yang ada pokok sahaja, yang mana untuk keselesaan pejalan kaki lah. Jadi insyaAllah kita boleh lihat doktor akan membuat next research lah, maybe dekat Kuala Lumpur ke, kat Putrajaya ke, dan sebagainya.
InsyaAllah.
Terima kasih. Jadi kita akan teruskan kepada pertanyaan kedua yang akan disampaikan oleh Puan Siti Nur Zaimah binti Muhammad Rashid yang tajuk pembentangan ialah berkaitan dengan RHA plastic cover blocks. Puan Siti daripada Politeknik kita mulakan tayangan video. Dan untuk semua, sekarang kita ni langsung ke Facebook dan YouTube.
Assalamualaikum warahmatullahi wabarakatuh. I am Erawati binti Mahrilal as a presenter today, and I'm from Polytechnic Sultan Idris Shah. It's an honor for me to deliver a presentation to all of you. The topic of my presentation is about RHA plastic cover blocks. First, I would like to talk about concrete cover. What do you know about concrete cover? Concrete cover is used during reinforced concrete work because it is really important to embed the steel reinforcement in the concrete in order to avoid the rebar gets corroded or rusty and to add fire protection. It has been used widely because it helps the structure to stand against premature failure of structure. Hence, using the concrete cover is very essential to the longevity of structure significantly without adding much cost. Table 1 shows the size and application of concrete cover, which are roof, slab, beam, lintel, column, wall, foundation, basement, and the size between 20 mm to 50 mm. The study by Neville 1997 described cement as a material with adhesive and cohesive properties that make it capable of bonding mineral fragments into a compact whole. It also the product of the silicate industry and is manufactured on the larger scale and used extensively in industrial buildings, building homes and other structures. It's time to look into the use of local inexpensive raw materials or industrial waste materials in replacing cement or build the construction. Cover blocks mixed with rice husk ash need to be widely marketed as a new building materials which to replace existing blocks in the industry. Rice husk ash or RHA is a byproduct of the goods for rice milling. Rice is a primary source of food for billions of people, especially in Asian region. In rice milling operation, approximately 78% of the weight is recognized as rice and the other 22% are rice husks. In paddy milling process, approximately 78% by weight is received as rice and the rest about 22% as husk. The unburned rice husk contain about 50% cellulose, 25 to 30% lignin and 15% to 20% silica, as reported by Ismail. 1996. Having pozzolanic properties not only gives technical advantage to the resulting concrete, but it also reduces cement consumption. Thus, the resulting benefits in terms of energy saving economy, environmental protection, and conservation of resources will be substantial. Now there is lack of research being done in Malaysia to develop the quality of concrete cover blocks available on the market. The agricultural residue that is under consideration in this study is the rice husk. The disposal of rice husk created environmental problem that leads to the idea of substituting rice husk ash RHA for silica in cement manufacture. As a result of the lack of emissions, the use of rice husk ash as a replacement for cement should cover the lack of cement as well as increase oil quality. Al Gunduz 2008 stated that the manufacture of concrete cover blocks should comply with international requirements specifying the product's particular properties. The use of rice husk in the manufacture of polymer composites therefore attract a significant interest from many rice-producing countries in the world. It is one of the most productive agricultural waste. Rice husk is a layer of rice grains that is difficult to cover and remove as a byproduct during the milling process from rice seed. As a waste product from the agricultural and forest waste industries, it is effectively free. This study was conducted out to release an environmental friendly project. The use of rice husk ash has been studied and applied as an additive to replace cement in mortar mixture. Therefore, The study used the resulting cover blocks is made of plastic and rice husk. Plastic is a substance composed of large organic molecules, carbon containing, which can be formed into different products. Long carbon chains that give plastic many useful properties are the molecules which make up plastic, a substance composed of long chain molecules in commonly called a polymer. Plastic is a synthetic chemical material that is mostly derived from fossil fuels such as oil, coal, or natural gas. Plastic is used in almost every manufacturing industry such as construction and others. And for materials, rice husk ash is a highly reactive pozzolanic additive in cement and concrete and can be used for the purpose of strength acceleration in concrete mixture containing less reactive pozzolans such as fly ash from the study conducted by Mehta 1989. The main raw material that are used in this study is carbon rice husk ash, which has been grinded into fine particles. It is found that rice husk ash is an ideal for use as a cement substitute because it contains a high silica content and can minimize the waste dumping issue. From the study conducted by Rosley, 2017. The use of rice husk ash as partial Portland cement replacement has given impetus to research and development of methods for producing energy and other useful industrial by-products, as reported by Katini 2010. RHA is a general term used to describe the type of ash produced from burning rice husks. Rice husks are the shell produced during the dehusking operation of paddy rice. The average composition of well-burned RHA is 90% amorphous silica, 5% carbon, and 2% K2O. 80 to 85% of silica can be found in the RHA reported based on CD 2008. The silica can be found in three forms. One of them is amorphous silica. Amorphous silica is reactive as pozzolans and can be replaced some of the Portland cement. Amorphous silica is found in RHA that is burned in specific temperature and duration as reported by Chinda Prasit 2007. Plastic are synthetic material made from polymer which are long molecules built around chains of carbon atoms, that is hydrogen, oxygen, sulfur and others, reported by Woodford 2019. Plastic can be molded and shaped by heat and pressure. A good plastic product takes the advantage of practicality such as low density, low electrical conductivity, transparency and toughness, as voted by Rodriguez 2006. Okay, the third one is methods. The samples for each RHA plastic cover blocks and cement concrete cover was made before conducting the test. The material used in order to produce RHA plastic cover blocks are 205 mm times 205 mm HDPE plastic bag, cooking oil and carbon rice husk ash. The apparatus required are cooking pot, spatula and PVC pipe that is cut into required height and tray. To produce one sample of RHA plastic cover blocks, prepare 12 sheets HDPE plastic bag and 20 grams of carbon RHA. Turn on the stove and put some oil in the cooking pot. Take 12 sheets HDPE plastic and put into the cooking pot. Stir until its shape became small and rounded. Put 20 grams of carbon RHA and keep stirring until the plastic RHA becomes halfway melting. The process takes only 3 to 5 minutes on low heat temperature of the stove. Turn off the heat and put the plastic RHA into PVC molds and let it rest and shape into round shape. It will harden after 5 minutes of rest. All tests are performed on RHA plastic cover blocks of similar dimension. To produce accurate dimension and weight is almost impossible due to its plastic properties, hence its use. The total number of RHA plastic cover block sample produced for compressive strength tests and water absorption tests are 6 samples per test and 3 samples are used per week. The total days of testing are 14 days or 2 weeks. The test methods are carried out, but due to the lack of standard for the concrete cover, the minimum size of the concrete cover that is 50 mm. Figure 1 shows apparatus used for compressive strength test. The samples are tested to identify their properties in compressive test strength after 7 and 14 days of curing period. The compressive strength test was determined by using computerized universal testing machine strength test machine. The average value of compressive strength for each type of plastic RHA cover blocks and cement cover blocks as control was calculated after the result. Figure 2 shows the water absorption test. The test for determining water absorption is done by submerging the RHA plastic cover blocks into water and put into cold temperature of 20 Celsius for 7 and 14 days. The initial weight and final weight of the plastic RHA cover blocks was recorded. The differences are then converted into percentage. Result and discussion. The analysis of the data was based on the testing that was conducted. The tests that was carried out are compression strength and water absorption. The result of the testing is evaluated and discussed as shown in Table 1. And Table 2 shows the various results for testing of the sample for 7 and 14 days and between cement and RHA plastic. From the big figure, it is found that cement at 14 days is the highest compressive strength with 9.1 MPa and the lowest value of compressive strength is cement at 7 days with 4 megapascal. It is also found that the result for 7 days show the compressive strength of RHA plastic is higher than cement, with that RHA plastic value 4.3 MPa. A study conducted by Cardini 2004 to 2009 revealed that the compressive strength of cement and RHA concretes increased with age. However, the RHA From this figure, it is found that cement at 14 days is the highest compressive strength with 9.1 megapascal and the lowest value of compressive strength is cement at 7 days with 4 megapascal. It is also found that the result for 7 days show the compressive strength of RHA plastic is higher than cement with the RHA plastic value 4.3 MPa. A study conducted by Cardini 2004 to 2009 revealed that the compressive strength of cement and RHA concretes increased with age. However, the RHA concrete attained lower value of compressive strength than the cement concrete at early age of 7 days. From the result obtained, it is shown that early 7 days RHA plastic cover block is having a better compressive strength as normal material in production of RHA plastic compared to cement. Figure 3 shows comparing the average of compression strength of cement and RHA plastic with these. At the result for 14 days showed the compressive strength of RHA plastic is lower than cement, with that value is 5.98 MPa. From this result showed cement having a better compressive strength when curbed. Reported by Ikpong 1993 that on various grades of concrete and with varying levels of cement substitution by volume reveals that the compressive strength increased with age but decreased with RHA content. As shown in table 2, it is clearly seen that the RHA plastic cover blocks cured in water gave lower permeability compared to cement. It shows that poor distribution of cover block is modified with the presence of RHA and the permeability is lower if curing is sufficient. This result confirms the importance of curing where it resulted in less permeable cover block. The conclusion of this study was carried out to evaluate the significance of utilizing agriculture and waste materials such as rice husk ash and wasted plastic bags and converting them into construction material. That is RHA plastic cover blocks, something useful for the construction industry. From the result obtained from this research, we can conclude that number 1, the result of this research shows that RHA plastic cover block needs more improvements to be added to be used in the construction industry as a construction material. Based on the British standard for concrete cover should have, etc. For number 2, the RHA plastic cover blocks is significantly lightweight when being compared to the standard concrete cover. The cost for the RHA plastic cover block is much lower because it does not use cement and cement is more expensive. Number 3, RHA plastic cover block have lower rate of water absorption when compared to standard concrete cover. Thus, the pozzolanic reaction between RHA and plastic modifies and or occupies the empty space in the pore structure that reduces the water permeability of cover blocks. And the last one but not least, RHA plastic cover block can be introduced as a new types of concrete cover in the construction industry, as it reduces the application of sand and cement to save costs while saving the earth by reusing the old and used plastic and utilizing the carbon RHA. Ladies and gentlemen, I think that's the end of my talk today. That's all and thank you.
Terima kasih kepada Puan Erwati binti Mahrila. Puan Erwati tidak dapat bersama kita, jadi beliau diwakili oleh Puan Siti Nuzaimah binti Rashid. Jadi Puan Siti dengan bahasa yang mudahnya, kebaikan rice husk ash ni ataupun kita panggil abu sekap padi untuk bidang pembinaan. Jadi setakat hari ini adakah pihak industri pembinaan telah menggunakan habuk serbuk sekap padi ni dalam pembinaan mereka?
Assalamualaikum warahmatullahi wabarakatuh. Berdasarkan pengetahuan saya sajalah ya. Setahu saya penggunaannya masih belum digunakan dengan begitu meluas. Walau bagaimanapun kajian-kajian memang ada banyaklah berhubung dengan produk bersangkutan dengan sekam padi, terutamanya pada kejuruteraan jalan raya, konkrit, itulah.
Setakat hari ni dari segi perbandingan dengan penggunaan simen sepenuhnya lah. Jadi dari segi pengurangan kos tu berapa peratus apabila kita guna sekam padi ni, berapa peratus dari segi dapat dikurangkan kos tu?
Maafkan saya sebab saya tak sempat nak mengira dia dalam bentuk peratus, tetapi untuk dari segi pengetahuan kita semua, apabila kita menggunakan simen, proses untuk menghasilkan simen itu sendiri memang agak mahal, sedangkan rest house ash ni adalah bahan kos memang lebih murah lah kalau nak dibandingkan antara dua jenis bahan ni.
Okey, soalan yang seterusnya kita open juga daripada para peserta lah. Jadi untuk yang seterusnya, dari segi kita tengok dari segi kekuatan rehas ni berbanding dengan simen, dia agak kita panggil agak kuat . Tapi dari segi ketelapan air itu macam mana? Seperti rehas ni tak apa bagus berbanding dengan simen.
Okay, baik. Kalau kita recap balik kepada pembentangan tadi, kekuatan concrete cover yang menggunakan simen sepenuhnya adalah 4 megapascal pada hari yang ke-7. Sedangkan kekuatan RHA plastic cover yang diinovasikan tu adalah 4.38. Jadi dia ada peningkatan sedikit pada hari yang ke-7, tetapi dia menurun pada hari yang ke-14. Jadi mungkin di situ kita perlukan lebih banyak sampel dan perlukan lebih banyak kajian ataupun masa yang lebih lama untuk kita ketahui takat sebenar kekuatan dia lah. Kalau pada pandangan saya, di situ kita dapat lihat simen lebih lama lah tahap kekuatan dia, sedangkan untuk RHA ni dia hari ke-7 yang paling kuat berbanding dengan simen sepenuhnya. Tetapi untuk water less water absorption, which means dia tidak akan mengembang apabila terkena air. Jadi kita agak gembira lah dengan dia punya hasil data dari aspek water absorption tadi.
Faham. Jadi apabila kekuatan RHA ni berkurang over the time, maknanya kalau selepas 7 hari dia akan mula berkurang kekuatannya lah kan. Jadi adakah dari segi industrial applicability tu mungkin kita boleh guna kat mana kalau ikutkan begini?
Memandangkan dalam cadangan paper ini dia digunakan untuk concrete cover dan saya percaya dia tidak ditindaki oleh daya yang begitu berat. Jadi dia hanya untuk cover, maksudnya dia tidak kena daya yang berat, jadi dia masih selamat untuk digunakan. Walaupun manapun kita boleh beban berat yang lain lah. Itu pendapat saya lah.
Boleh puang ulang semula sebab kita agak terganggu sikit dia punya sinyal.
Maaf. Okey, maksud saya tadi sekiranya kita gunakan dia kepada struktur-struktur yang tidak mengalami beban yang berat seperti penutup ataupun penutup longkang, jadi dia akan worth it lah maksudnya. Dia tidak boleh kepada struktur yang menerima beban yang berat lah.
Okey, soalan yang terakhir lah. Jadi apabila tim puan telah berjaya melaksanakan kajian ini, jadi apakah perancangan di masa hadapan untuk meneruskan kajian sama untuk lain-lain parameters untuk penggunaan abu skabadi ni.
Okey, baik. Cadangannya ialah kita boleh menambah baik dari segi nisbah dan juga bilangan sampel yang kita akan laksanakan uji kaji. Itu daripada bulan kami.
Okey, terima kasih. Kita telah tamat kepada sesi kita. Jadi
Encik, saya terpaksa off kamera dulu ya.
Siapa kita nak foto sikit.
Okey. Kita kena foto. Okey.
Dr. Zanaria pun boleh keluarkan suara sikit baru dia keluar video Okey.
Okey.
Sekejap dia ambil gambar. Okey.
Kalau tadi ada presentation. Sekejap nak ambil. Okey, kita ada tu ya.
Telah tamat dua sesi pembentangan pada hari ini, iaitu daripada landscape kita dan daripada Puan Erwati yang dipunyai oleh Puan Siti Nozaimah lah. Jadi insyaAllah kita berjumpa lagi di sesi Greentech Pertanian South Malaysia di masa-masa akan datang. Terima kasih.
Terima kasih.
Insya-Allah. Terima kasih.